Welcome to my lecture on regression. What is regression? Like correlation, regression is also a test of a relationship between variables. But with regression, you can make a hypothesis about which variable is predicting a relationship. For example, with regression, you can say a number of likes on Instagram predicts happiness, or happiness predicts the number of likes on Instagram. It is a way of predicting the value of one variable from another. A linear regression is calculated based on the equation of outcome plus model plus error. A score of the dependent variable y can be described as the intercept plus slope plus error. Let me explain what intercept and slope really mean. Let's look at the graph on the left. Vertical axis represents the scores of the dependent variable or the outcome, and horizontal axis represents the scores on the independent variable or the predictor. The red line indicates a positive relationship between the predictor and the outcome because every time a score of the predictor increases, a score of the outcome also increases. The green line indicates a negative relationship between the predictor and the outcome because every time a score of the predictor increases, a score of the outcome decreases. Intercept is the point at which the lines cross the vertical axis, basically the starting point of the regression line. The slope indicates the rate of predicted change in y given one unit of change in x, showing how much y is predicted to change every time x changes by one score. In this graph, both red line and green line have the same intercept but different slopes. Now let's look at the graph on the right. Here, all three lines have the different intercepts, but they have the same slopes. Because three lines begin from different points on the y-axis, but have the same degree of change in y as x changes. With intercepts and slopes, we can test to what extent your independent variable predicts your dependent variable in your hypothetical model. Let's use the same example from the correlation analysis. But this time, we are not testing just the relationship between variables, but the prediction of one variable over another. We want to find out if and to what extent the number of likes you get on Instagram predicts your overall happiness. Now, let's run regression using R. Here I have the data from 30 participants with scores on likes on Instagram, happiness, and attractiveness. I want to run a linear regression to see if likes on Instagram predicts happiness. To run regression in R, you can go to Statistics, Fit Models, and click Linear Regression. You can pick your dependent variable here, in our case, happiness, and an independent variable here, in our case, likes on Instagram. Dependent variable is the outcome of the relationship, and independent variable is the predictor. You can click OK. And here's the result of the regression. You can see the intercept, which is 2.16, and the slope, which is 0.04, and the standard errors, plus the t-value and the p-value. What is important is the slope and the standard error, but also the p-value. The p-value indicates whether your independent variable significantly predicts your dependent variable or not. In our case, the p-value is bigger than 0.05, which means that likes on Instagram did not significantly predict happiness. What is also important to see is the value for R-square. R-square indicates the variability that is explained in dependent variable by your model. In this case, independent variable. So this indicates that 12.31% of variability in happiness was explained by this model. Now let's talk about multiple regression. Multiple regression sounds fancy, but it is actually just a normal regression model with more than one predictor. The regression equation looks a bit more complicated because it is longer, but it is longer just because we now have more than one intercept and slope. But other than the number of predictors, multiple regression is no different from a normal linear regression. A research question of multiple regression has one dependent variable, in our case, happiness, and more than one predictor, in our case, likes on Instagram and Instagrammers' attractiveness. We can investigate whether the number of likes on Instagram and attractiveness predict overall happiness together. To test the multiple regression, you can go to statistics, fit models, and linear regression, just like how you tested a simple linear regression model. But in this case, you keep the dependent variable as it is and include one more independent variable. In our case, likes on Instagram and attractiveness. And click OK. As you can see, we can see the intercept and the slope for attractiveness and the slope for likes with standard errors, t-values, and significant values. Important to see are the significant values of the p-values. As you can see, the p-value for attractiveness is bigger than 0.05, which means that physical attractiveness of Instagrammers did not significantly predict people's happiness. Similarly, the p-value for likes on Instagram is also bigger than 0.05, which means that likes on Instagram also did not significantly predict happiness. The R-square is 0.1232, which means that 12.32% of variability in happiness was explained by attractiveness and likes on Instagram together. That was it for today's lecture. Thank you for watching and see you next time.